When power disappears, everything else follows. Cities slow, then stop. Hospitals lose the quiet certainty that machines will respond when needed. Airports fall dark, not from chaos, but from absence. Modern life depends on continuity so complete that its failure feels unthinkable. And yet, failure is always possible. Grids overload, storms sever lines, human error compounds mechanical weakness. In those moments, there is no room for recovery time. Power must already be there. This factory exists for that reason alone, not to produce electricity for everyday use, but to ensure that when entire systems collapse, power does not. Its scale reflects the stakes. Nothing here is built for convenience or speed. Everything is built for permanence. Rows of generators operate in parallel, not because demand requires it, but because redundancy does. Each unit assumes the others may fail. Foundations are reinforced beyond normal limits. Connections are oversized, over-supported, and deliberately conservative. The system does not chase efficiency, it chases certainty. Power does not move casually through this space. It is guided, buffered, and controlled at every step. Cables are armored, routed without stress, labeled without ambiguity. There is no improvisation hidden behind panels. Everything is visible because nothing is allowed to be assumed. This is not a single machine, it is a chain of dependency. Generators feed busbars feed switchgear feeds multiple outgoing paths, each designed to carry more than it should ever need to. Every path leads outward, beyond these walls, to places where interruption is not an option. Hospitals do not appear here, but their dependence does. Emergency networks are not named, but their presence is implied in every branch. This factory does not imagine its users, it prepares for them. Control exists without interference. Systems watch systems. Data flows constantly, not to demand action, but to confirm stability. Alerts remain armed and silent. Redundant controls mirror primary ones, not waiting to be needed, but already synchronized. Nothing reacts because nothing is wrong, and that is the goal. Failure is anticipated, not feared. Backup generators operate alongside primaries, sharing load even when no threat exists. They are not reserves, they are participants. If one disappears, the system should not notice. This is what makes failure unacceptable here, not because the consequences are dramatic, but because they are immediate. When grids fail, there is no pause for explanation. The lights must already be on. That requirement defines everything that follows. Before any component becomes part of this system, it enters under the same assumption. It may be the last thing standing. Materials do not arrive casually. They enter through controlled zones that treat every component as critical by default. There are no commercial markings, no variation in handling. Every unit is heavy, sealed, and intentional. Movement is slow because speed adds uncertainty. Identification is not an afterthought. Every piece carries its history with it. Serial numbers, tracking data, and embedded verification ensure that nothing anonymous enters the system. No component is trusted because it looks correct. It is trusted because it proves itself. Approval is automated, not to remove responsibility, but to remove discretion. Material grades, tolerances, and compatibility are confirmed against fixed standards. If something deviates, it does not argue, it is removed quietly. Isolation is not punishment, it is discipline. Materials wait without progress until every parameter aligns. Stillness here signals control, not delay. When clearance comes, movement resumes in exact order. Nothing overtakes, nothing reroutes. The system prefers predictability over flexibility. Verification deepens as materials advance. Dimensions are measured without assumption. Surfaces are inspected for flaws too small to see, but large enough to matter years later. Rejection happens without commentary. The system does not explain itself. Only components that meet every requirement proceed. They enter restricted zones where environment itself becomes a tool. Temperature, humidity, and air quality are regulated, not for comfort, but for consistency. Materials are handled without touch, guided by alignment rather than force. Sensors remain active through every second. Stress is monitored even when nothing moves. Stability is confirmed before progression is allowed. Eventually, everything stops again, not because the process is finished, but because the next step requires absolute readiness. Materials are staged in the exact order they will be used. No part is early, no part is late. At the boundary of assembly, the system pauses one final time. Nothing has been built yet, and yet the outcome is already constrained by everything that has come before. Because once construction begins, there is no room left for correction. Assembly begins without announcement, not as a moment of creation, but as a continuation of discipline. Components move into place because the system allows them to. Nothing here is forced. The assembly floor is not a workspace in the usual sense. It is a sequence of decisions already made. Mounting frames are anchored deep into reinforced concrete, aligned long before the first component arrives. Tools wait powered and idle, not because they are unused, but because timing matters more than speed. Each station performs one task, and only one. There is no overlap, no shortcut. Precision here is not about accuracy alone. It is about repeatability over decades. When a core structure is lowered into position, it settles without resistance. Guides meet sockets as if they were always meant to. Fasteners turn until they stop themselves. Torque is reached, not estimated. Load paths are distributed evenly before the system is allowed to move on. Data confirms what the structure already knows. Alignment values stabilize within narrow margins and stay there. Locking mechanisms engage and do not release. From this point forward, the foundation does not negotiate with force. Additional components arrive in sequence, each dependent on the previous one. Interfaces meet flush, seals compress uniformly. Redundant paths are installed alongside primary ones, not as backups, but as equals waiting for relevance. Human presence remains distant. Engineers watch data, not hardware. Adjustments occur internally, driven by sensors and logic rather than hands. When values settle, confirmation is silent. The build phase ends without ceremony. But assembly alone does not earn trust. That comes only under pressure. The system moves into testing, not to prove it works, but to prove it endures. Enclosures form around it, isolating without hiding. Nothing is concealed. Every cable and interface remains visible because failure must be observable before it becomes real. Baseline values appear first. Voltage, frequency, thermal behavior. Everything sits exactly where it should. Then limits are raised. Load increases gradually, deliberately. Internal forces rise together, balanced and controlled. No vibration escapes into the structure around it. Sensors respond faster than the stress they measure. As demand grows, redundant systems engage without instruction. They do not announce themselves. They simply begin sharing the work. Heat increases, then stabilizes. The system absorbs strain without complaint. Failure is introduced carefully. One subsystem is pushed beyond comfort. Warnings appear contained and precise. Compensation begins immediately. Load reroutes. Stress redistributes. The imbalance disappears without interrupting output. A sharper disturbance follows, an abrupt spike designed to overwhelm logic. Alarms sound briefly, then stop. Protocols activate faster than attention can follow. Isolation occurs where needed. Continuity remains intact. The system holds under sustained pressure, not for moments, but for duration. Hours matter more than peaks. Values remain stable. Surfaces show no fatigue. When stress is removed, the system does not recoil. It returns to normal without overshoot, without correction. Testing ends the same way it began, quietly. Only then is the system allowed to leave isolation. Enclosures retract in sequence. Supports disengage without resistance. Transport platforms take the weight effortlessly. There is no evidence of what the system has endured. It moves forward through a factory built to receive it. Bus bars, transformers, and switching assemblies wait in alignment. Connections descend slowly. Contacts meet evenly. Primary paths engage first, then secondary, then tertiary. Each confirms stability before the next proceeds. Data links activate in parallel. Information flows outward, integrating the system into a larger awareness. Power begins to move, slowly at first, then steadily. Output rises without drama. Regulation holds voltage and frequency within narrow bands. Cooling responds without drawing attention. Redundant systems track conditions without acting. Soon, the system reaches operational levels. Nothing changes. No alarms, no adjustments. It behaves as if it has always been here. Time passes, operation continues. The system does not demand observation. Engineers review trends measured in years, not minutes. Data confirms what experience already suggests. Continuity holds. Decades later, the system still stands at the center of an expanded facility. Surfaces show wear, but not weakness. Components have been replaced, sensors upgraded, interfaces refined. Every change respects the original structure. New generations observe from elevated platforms, using better tools to ask the same questions. Predictive models extend far beyond the present. Nothing urgent appears. Even when external disturbances strike the grid, the system responds as it always has. Load shifts, demand is absorbed. Output never falters. Engineers glance at the data, then look away, because this is not an achievement to be celebrated. It is a condition to be maintained. The factory grows around the system layer by layer. Old infrastructure stands beside new. At the center, the core remains unchanged. There is no shutdown sequence here, no final moment. Power continues to flow, quietly, reliably. Most people will never know this place exists. They will only notice when it doesn't fail. And because of factories like this one, it usually doesn't.